I'm Talia. Welcome if you're new, welcome back if you're not. I am a high school senior who loves teaching others about chemistry, and I make YouTube videos to discuss different chemistry topics. This week, I'm going to be talking about solubility. So if you need help with solubility or just want to learn more, feel free to keep on watching. And without further ado, let's get started. Okay, so I'm first going to be explaining what solubility is. So solubility is how much solute will dissolve in a solution in order to create a saturated solution. And if you remember from the beginning of this unit, solute is what gets dissolved and the solvent is what does the dissolving. And so your next question might be, what is a saturated solution? And a saturated solution is when no more solute can be dissolved. So all the possible solute has been dissolved in the solvent, and if you pour in any more, it'll just sit at the bottom and won't dissolve in. So compounds that dissolve well in water are called soluble, and when a compound does not dissolve well in water, it's called insoluble. And this is what the basis of this video is going to be about. Some ions, when you match them with other ions, and you form a compound, that compound will be insoluble in water. And that is the basis of solubility. Some ions will be soluble with some and insoluble with others. Insoluble just means that when you form that compound, it will fully dissolve in water. So if a compound is insoluble, it will form a precipitate in water. And a precipitate is just a solid compound that has a low solubility in the solvent. So that means that most of it just stays solid at the bottom and it is not going to dissolve into the water. So just a general point, when you increase the temperature of a solid or a compound, that will also increase the solubility. It is different. Solubility changes a little bit with gases, but that is something you will continue to learn if you take AP Chem. So to remember which ions are soluble with which other ions, we have a solubility table that I took a photo of, and you will most likely, if you are taking honors chem, have one on your formula sheet or something, and if you are in AP Chem, you will be asked to memorize at least just the basic solubility rules. On this side, I have all of the anions, and on this side are all of the cations. And so this solubility table just shows which anions are soluble and insoluble with which cations. And you can look, we'll do this in purple, you can look over here, it says which combinations are soluble and insoluble. So for instance, if we take chloride over here, that will be soluble with any other cation except for silver plus, Pb2 plus, and Cu plus. Those will be insoluble with chlorine, with the chloride ion. So that means AgCl, if you put it in water, will not dissolve. The compound is insoluble. On the flip side, let's take sulfide. If we put that with beryllium 2 plus, we will get a soluble compound. So if you match sulfide with something that is not an alkali ion or any of the other ions on that list, then the compound will be insoluble in water. And alkali ions, remember, are the group all the way on the left of the periodic table. So that's basically just how this works. You see, and you can do it on the flip side as well. If you have lithium, you can put it with any anion and it will be soluble. But if you have calcium, you cannot match it with sulfate because that will not be soluble. So now using that chart, we are going to determine if these said compounds are soluble. So first we have lithium carbonate. So I'm going to go on my table and find lithium, and I'm going to see that it is soluble with all anions, which means that lithium carbonate is going to be soluble. We can also double check that by going down to the carbonate section and seeing that it is soluble with alkali ions, H plus and NH4 plus, and lithium is an alkali ion. So I'm going to write that Li2CO3 is soluble. Now let's check CuCl2. So chlorine is insoluble with Cu plus, but soluble with Cu2+. And this is something I wrote up here that I forgot to mention, that on the solubility table, you have to pay attention to the charge on the multivalent metals. as sometimes one type of the element will be insoluble with something while the other type will not. For instance, Pb2 plus is insoluble with sulfate, but Pb4 plus is soluble. So for instance, like if you look at sulfate here, it is insoluble with Pb2 plus. So if you have a compound with Pb4 plus and sulfate, that is soluble. So just be careful on the charge of the multivalent metals. And this is a perfect example. In chloride, Cu plus is insoluble, but Cu2 plus is soluble. And we know that in this compound, we are using Cu2 plus because there are two chloride ions, so the charge is going to be 2 minus, and then the Cu charge will be 2 plus because there's only one of them. So then that means this compound will also be soluble. Finally, we have AlOH3. So let's go to OH. We see that it is soluble with alkali ions H+, NH4+, Ba2+, and Sr2+, but insoluble with everything else, which means that it is going to be insoluble with aluminum. So that is how you determine solubility. Make sure to look at the charge of your multivalent metal because that will change if something is soluble or not. So now we are going to go into a discussion of solubility and reactions. So two solutions of ionic compounds, so two compounds that are soluble, can form a precipitate and then another solution. This reaction that takes place can be written out in three different equations. We have the formula equation where just the double replacement is shown. So the soluble compounds are written with AQ and the insoluble compounds are written with S. And AQ is aqueous, and that is different than liquid because aqueous represents a solution, whereas liquid just represents the liquid form of a compound. And the insoluble compounds are written with S because they are a precipitate and will not dissolve. We don't split anything up. It's just like double replacement equations we've learned previously. You just write parentheses AQ or parentheses S. Then we have the complete ionic equation, where aqueous solutions are dissociated into the ions, which we learned about in the previous video, and solid compounds that are insoluble remain undissociated, so they do not split into ions. Then finally, we have the net ionic equation, where identical ions are canceled out and remaining substances are written out in the equation as reactants. And these substances are the ions that make up the precipitate. So you'll have ion yields precipitate. The solid is still written as a product, and in the reactants, the cation is written before the anion. The ions that don't participate in the formation of a precipitate, they are called spectator ions, and they just get canceled out when you go from the complete ionic equation to the net ionic equation. So those are the three different equations you can use in solubility reactions when two solutions are mixed together. And you need to determine if there's a precipitate and like which compound the precipitate is in the double replacement. And you use your solubility table to determine which compounds will be soluble and which will be insoluble. So you will always start with two soluble compounds. So let's try an example. So we have FeCl3 and NaOH. Before we begin, let's just confirm that these are both soluble. So we have FeCl3 will go to chloride ion. It is soluble with iron. And the other one was NaOH. And hydroxide is soluble with sodium because sodium is an alkali ion. So I am going to start by writing my formula equation. So I have FeCl3. And remember, we are going to write AQ plus NaOH, which I will also write AQ after, is going to yield, and remember, a double replacement, the metals switch places and the non-metals switch places. So we will end up with FeOH3, I'm going to leave a little space, plus NaCl. Now we have multiple things to do with this equation. First, just before I begin, I wrote FeOH3 because in the first solution with chlorine, there are 3 chlorines. So that is a 3- charge, so the iron has to be 3+. So now let's balance before we write which products are soluble and which are insoluble. So my OHs are not balanced. There are 3 on the products and only 1 on the reactants. So I am going to put a 3 as the coefficient in front of NaOH. And then I'm also going to put a 3 in front of NaCl. And now we are balanced. So now let's see what is soluble and what is insoluble. So let's first check iron with hydroxide. So iron 3 plus is not soluble with hydroxide. So then that means that FeOH3 is going to be our precipitate, and we are going to mark it with an S for solid. Now let's check NaCl. We have chlorine, the chloride ion, which is soluble with sodium. So that is going to be written as aqueous. Okay, that is our formula equation. Okay, so next let's write our complete ionic equation. So, as a reminder, soluble compounds will dissociate. So FeCl3 will dissociate into Fe3+, and I'm going to write the state plus 3Cl-, which is also aqueous, and then our coefficient is going to come into our dissociation equation as well. So we have 3Na+, plus 3OH minus, that is going to yield 3Na plus 3Cl minus plus FeOH3, which is still a solid because that is a precipitate. So finally, we are going to do our net ionic equation. And remember, for that, we first have to figure out our spectator ions. So we want to cancel out which ions appear on both sides of the equation, which is chlorine, sodium, and those are our spectator ions. So now we are going to write our net ionic equation. So we'll start with the cation, because there's no iron on both sides. There's the iron ion on the left side, and iron is in a solid on the right side. So therefore, Fe3 plus cannot cancel out and be a spectator ion because it's on only one side of the equation. So Fe3 plus 3OH minus is going to yield FeOH3, which is a solid. And now, just for an extra little bonus point, we are going to write down our spectator ions, which are Cl minus, or I'm going to write my cation first. So our spectator ions are Na plus and Cl minus. So that is a pretty good introduction on solubility and how to determine if compounds are soluble or not in water, and also how to use solubility and apply it to reactions to figure out precipitates and all of that good stuff. So that was this week's video. Next week, I will be talking about selective precipitation, which is a further discussion on solubility. So make sure you are really solid on solubility, dissociation, just everything from this unit and all of chemistry so far in order to join me back on our chemistry journey and learn about selective precipitation. If you have any questions or comments, feel free to leave them down below in the comment section, and I will do my best to answer them. I hope you enjoyed this video, and good luck with learning the rest of your chemistry.